Hi, how's everybody doing? Okay, we gathered you here to talk about electrical safety, and I'm here to talk to you from straight from basically from being out in the field and having lots of experience. So hopefully I can answer any of your questions. If you might have any, feel free to ask them. But we're going to talk about electrical safety and the NFPA 70E and wearing the proper PPE when you're working on electrical systems. It's essential that we do this and we do it correctly. If we don't, we might wind up in a burn center and even somewhere else that could be worse. We're looking at personal protective equipment, PPE, and that's what it stands for, the acronym, but also stands for partially protected employee. And what I mean by that is that you can wear all the stuff we're going to talk about today, and if you're involved in an arc flash, there's no guarantee you're going to walk away without having a burn. We're not talking about a little tiny arc. We're talking about a tremendous arc that can come up to 36,000 degrees Fahrenheit in less than 1/10 of a second, or basically if we look at it in cycles, we're talking 6 cycles or less. Okay, so 6 cycles or 60 cycles in a second, so we're talking about a very short period of time, a blink of an eye. And in that blink of an eye, your whole world could what? Change. The FR-rated clothing we're going to mention, the face shields and all that stuff is designed to prevent a 3rd-degree burn. You still may receive a burn, but hopefully it's 2nd degree or less. What we mean by that, a 2nd-degree burn is a curable burn. It's a burn characterized by blisters. A 1st degree is a sunburn. Most of you have experienced that, right? 2nd degree, blistering of the skin. 3rd degree is total destruction of the skin, and you're going to need skin graft surgery. So all of this stuff we have up here on the stage for you is designed to prevent that 3rd-degree burn. Kind of give you an idea of what we're talking about. 1 calorie, 1.2 calories is enough to burn your skin 2nd degree in 1/10 of a second or 6 cycles. Now that's a blink of the eye. Your skin temperature is raised to 176 degrees and you have a 2nd-degree burn. 1.5 calories per centimeter squared is enough heat energy to burn you 3rd degree. Raises your skin temperature to 205 degrees Fahrenheit in 1/10 of a second. It destroys the nerve endings, it destroys the sweat glands, and you now you're facing skin graft surgery, and you're fighting to survive. This is a warning label that you see around the plant. Many of you are going to start seeing, some have already got them done. Across the country, there are companies actively involved in performing an arc flash study in accordance with the NFPA 70E and the IEEE standard 1584. As a requirement of the National Electric Code, we put these labels on the equipment, where a qualified person who has received safety training on the hazards involved can pick out what he or she needs to wear to prevent that 3rd-degree burn. So the first thing we look at is the flash hazard boundary. In this case, it's 3 feet 4 inches, and that is not a safe boundary. Let me repeat that. That is not a safe boundary. What that means is if I'm standing 3 feet 4 inches away and there's an arc flash that occurs on a piece of equipment, I could still receive a 2nd-degree burn, unprotected skin. Any closer than that 3 feet 4 inches, that same unprotected skin will now get what? A 3rd-degree burn. So I must have on the proper PPE, the FR-rated shirts or pants or suit, whatever it might be, in order to cross that flash protection boundary. So when we look at this equipment that we're talking about, the coveralls, the shirts, the flash suits, we have to look inside and understand the labels that are in there are informational labels to tell us what they're rated for. The next one, it says there's 4.9 calories per centimeter squared at 18 inches. Now that 18 inches is a working distance or from your chest to the equipment, and it doesn't consider any door that happens to be in the way. So if we were to get closer, the calories would go up exponentially. If we get further away, the calories go down exponentially. But at that 4.9, just a minute ago I said 1.5 was enough to burn us 3rd degree. So what can 4.9 do? Okay. So we have to wear clothing that says in the label of the clothing that it meets or exceeds that 4.9. Now the NFPA 70E has set up categories for us where we know what the calorie ratings are based on the hazard risk category of the NFPA 70E, and they've really made it quite simple for us to follow. The next section talks about the voltage level. Here it's 0.48 kV or 480 volts. Now we must avoid shock. And I hope you guys understand that there are actually 3 hazards. Number 1 is shock, number 2 is the arc, and number 3 is the blast. The shock always comes first. Let me repeat that again. The shock always comes first. You can be burnt to a crisp and still live. But if you're electrocuted, you're by definition what? Dead. Does it matter what your body looks like then? No. I mean, you might make the difference between an open casket and a closed casket, but guess what? You're still where? At your funeral. Okay? So shock is always number 1. In order to prevent us from being shocked, we've got to wear voltage-rated gloves and use voltage-rated tools. Here's the gloves in a pictorial format, double aught, the first one. The second one is aught, rated for 1,000 volts. The 1 is rated for 7,500 and 2 rated for 17. Now these gloves must be tested every 6 months by an independent certified laboratory. And they must be tested and checked by you every time you use them for air leaks or any kind of defects in the glove. The leather protector that's over the glove must stay with the glove. It is designed to protect the rubber glove itself. It is not a work glove. You cannot take this glove and go out and cut a bunch of all thread and then go back and put it on your rubber gloves. You just contaminated your rubber glove. A small pinhole in this rubber glove will get you killed. Electricity will find it. So we have to do a good job of inspecting the gloves before we use them. We want to make sure our leather protectors are kept with the gloves and are not used as work gloves. I knew a person in the Northwest who was a good friend of mine. And he was a mechanic who was cross-training to electrician. He was asked to hook up a cable to a portable generator that the contractor the next morning was going to use. Well, he went out and he hooked up some cable to it, and he didn't check back at the motor control center, but back in the motor control center, the circuitry was telling him that there was a ground fault, and he had wired one of the phases to ground. Well, he didn't check that, so he wasn't aware of it. He went home. The next morning he came back to work. They asked him to go out and troubleshoot because the contractor was complaining that they were getting shocked off the generator. So he went back down there to troubleshoot. He took 2 supervisors with him. He's got his voltmeter. He supposedly has on his PPE he's supposed to have on. He's sticking the voltmeter everywhere he could possibly think of to try to get some kind of a measurement, but he's getting pretty frustrated. Once again, he doesn't have the training and the background. He's got 2 supervisors overlooking him, which increases his what? Frustration level, perhaps. And out of frustration, for nobody knows why, he grabbed the plug with a cable that connects the generator to the cord that was going to the motor control center, and he pulled it apart. When he pulled it apart, that plug was energized. He became the new path. Hand to hand. That's a very dangerous path because it goes where? Right through the heart. He stood there and was electrocuted in front of the 2 supervisors who could do nothing because the actual disconnect for it was too far away. That young man left 3 small young children and a young wife. Where was his gloves, do you think? Right here on his pallet, on his belt. If he had been wearing the voltage-rated gloves, he'd still be with us. If he'd been wearing the voltage-rated gloves, his family still would have had who? Daddy still would have been there. It's a tragedy when we hear about stuff like that. It's even more so when it hits home and it's somebody you know. Prior to this happening, I kind of complained about wearing gloves because I went 22 years without wearing gloves. I stopped complaining after that accident, and I started wearing them no matter what. I don't care if I'm sweating. I don't care if I can't handle the screw or not. I'm not leaving my children or my wife, and I hope you don't either, like he did. They found his gloves once again right here. Where should they have been? Right there. Now you can't fix mistakes sometimes. Pulling the cannon plug apart, Yes, that was a mistake. But what was he trying to do? Fix the problem, and in desperation, he did that. Had he had on the gloves, it would at least protected him against that what? Mistake that he had made. That's why we're wearing them. That's why we're wearing them. I wear the gloves to prevent all shock. And if you can't handle it because it's too small of a wire, or you've lost too much dexterity, or you don't like the sweat in your gloves, or whatever reason you come up with, then you need to shut it down. When you shut it down and you prove that it's de-energized, you can then what? Take the gloves off and work it as a de-energized piece of equipment. Some ARC facts you might not be aware of is that over 80% of all electrical injuries are due to ignition or flash burns, arc flash, and ignition of flammable clothing. Cotton. Now, I know you've probably heard that, oh, just wear 100% cotton. That's all electricians have to do. 100% cotton is not adequate. It's only good for category 0, which is minimum job task and minimum energy levels. Once you get to hazard category 1, everything changes. Hazard category 1 and above, we must have on FR-rated clothing, not cotton. You can have cotton underneath, but you got to have the outer layers got to be FR-rated. So cotton itself is not that good of a protection. That doesn't mean that we just ignore it. No, we do wear it. But it does mean that we don't wear nylon, rayon, polyester, acetate, any type of synthetic blend that will melt into our skin under an arc flash condition, because that will worsen the damage to your body. Wearing the polyester shirt alone will cause a third-degree burn, even if the surrounding temperature is not that high of a level to create a third-degree burn, because it dissolves into your skin and destroys everything. Since 1995, those type of materials have been strictly prohibited by OSHA. I still travel the country today, and here it is, 2009, and we still have people who have never heard about what we're talking about. It's amazing. We cannot be out there wearing the nylon windbreaker. You know, the one you got for a safety logo last year? Put it on the back of your shirt, and you're out there wearing it in the substation. That'll get you what? Burnt severely. Okay, so we can't do that. Arc temperatures, once again, reach temperatures of 35,000 degrees Fahrenheit, 20,000 degrees Kelvin. And it does it how fast? 1/10 of a second, okay? Over 2,000 people are admitted to burn centers with severe electrical burns every year. As far as I'm concerned, that's 2,000 too many. I don't know if you've ever visited a burn center, but it is one of the most painful places that you could possibly visit. Bless those people that work there, but I tell you what, you don't want to be there as a patient. So when I look at the NFPA 70E, I do my best to follow it the best I can. Will I make mistakes? Yes. Everybody here is capable and will make a mistake. But you hope that when you make that mistake, you are covered by the proper PPE so that mistake doesn't turn into a major tragedy. Probably the best advice I could give you. Think about what you're doing. Question about what you're doing. Understand what you're doing. Know if you're doing it the right way or the wrong way. If you don't know, then find out. That picture is a picture of a gentleman who was burnt, 40% of his body, and that picture happens to be me. I'm not here to share with you about some textbook. I'm here to share with you from my heart what happened. I was involved in a 7,200 volt arc flash on a high voltage switch, very similar to what we have in the back of the room. I was working on a job, and it was my task to get all that equipment up and running, and I made a few mistakes, very costly mistakes. One is when I opened the switch that morning, it happened to be on a Monday, but it opened the switch up, and I did not look inside to verify that all 3 blades were open. And as you can see, that equipment has windows where you can what? Look through. So 2 big mistakes. 1, didn't verify the blades were open. 2, didn't do a zero energy check. Somehow, and I don't know how, because my mind just blanked it out, but somehow I got across 7,200 volts. It went in my right leg and blew out where I was sitting on my toolbox. It caught my shirt on fire, and at that time I was wearing a 65% polyester, 35% cotton shirt. It was a short sleeve shirt. That might not make any difference to you, but it will here in just a minute. The short sleeve shirt, but down at this portion of my body, was exposed, and it was burnt 2nd degree. Where the shirt was 3rd degree. So the polyester had melted into my skin or diffused in my skin and created the 3rd degree burns. I had on a large belt buckle, and that belt buckle got so hot, not from electrical contact, but from absorbing the heat energy, it got so hot that it burnt a nice big hole in my stomach, and it was very difficult to get that patched up and skin graft that. I was wearing a watch. Okay, it was a rubber watch, but you know rubber melts, right? Most of those watches are metal backings. Guess what they do? They absorb heat energy. It got hot enough to burn 1/4 of an inch into my skin and caused, of course, more skin grafts. My wedding ring I had on, they were able to remove the wedding ring so I didn't lose my finger, but it could have very well led to losing my finger. It was just fortunate that it didn't. So when you go to work on electrical equipment, what's one of the #1 rules we talk about? Remove all what? All jewelry. I mean, that includes everything. Now today I have to go through a whole list of stuff. You used to be able to just say remove your rings and watches. Now it's earrings, nose rings, cheek rings, eyebrow rings, you know, tongue rings. I mean, anywhere you got a ring, take it off, because what will it do? It'll absorb the heat energy. Not just, it can be a conductor and cause a short, but the biggest part is it'll absorb that heat energy. And then it's got to what? Dissipate that heat energy into your body, and as I already mentioned, your body is not capable of handling that. I was blown 45 feet away from the